Hello everyone to my statistics guiding class, and today me, Sweta Tuladar from Atus Online Study is going to give you guidance on estimation. So, estimation. Statistical estimation is concerned with methods by which population parameters are estimated from the sample statistics. In this picture, we can see that population we can see that there are population and samples 2, 5, 8 and 11 has been taken, and in this estimation chapter what we are going to do is we're going to calculate values from these sample people 2, 5, 8 and 11 and draw overall conclusion on the entire population, that is from 1 to 12. So, before starting with estimation, let's be familiar with some of the important terminologies. Statistics. It's characteristics of sample. Parameter. They are characteristics of population. Estimator is sample statistics used to estimate population. And estimate is specific estimated value of estimate. So here we have notations for mean, proportion, standard deviation, and size for statistics and parameter. For mean, we have x bar as a notation for statistic mean, and mu as notation for mean of parameter. For proportion, we have p small p as a for statistics and bigger p for parameter. For standard deviation, we use small s for statistics, whereas sigma for parameter. And for size, we use small n for statistics, whereas a big N for parameter. Criteria of good estimator. There are 4 characteristics required to be a good estimator, and they are as follows. Unbiasedness. An estimator is said to be unbiased if its expected value is identical to the population parameter which is being estimated. The expected value of the sample average is considered to be an unbiased estimator if it equals the population mean which is being estimated. Consistency. A consistency refers to the effect of sample size on the accuracy of the estimator. A statistics is said to be a consistent estimator of the population parameter if it approaches the parameter as the sample size increases. Efficiency. An estimator is said to be efficient if its value remains stable from sample to sample. The best estimator would be the one which would have the least variance from sample to sample taken randomly from the same population. Sufficiency. An estimator is said to be sufficient if it uses all the information about the population parameter contained in the sample. For example, the statistic mean uses all the sample values in the computation while mode and median do not. Remarks. Sample mean is good estimator of population mean. Sample proportion is good estimator of population proportion. Sample standard deviation is not a good estimator of population standard deviation. Standard error. The standard error of a statistics is the standard deviation of its sampling distribution or an estimate of the standard deviation. Here we have formulas for standard error of mean and standard error of proportion. When population size is unknown, we use this formula for standard error of mean and this formula for standard error of proportion. Similarly, when population size is known, we use this formula for finding out standard error of mean and this formula for finding out standard error of proportion. Types of estimate. There are 2 types of estimates, and they are point estimate. Point estimate is a particular sample value. Statistics is used to estimate unknown population value, that is parameter. This method ignores error and hence also called error-free method. And here we have sample mean is equal to population mean. Sample proportion is equal to population proportion. And similarly, S is equal to sigma, or just that is adjusted sample standard deviation is equal to sigma, and adjusted variance, that is S square, is equal to sigma square. Interval estimate. Interval estimate is an estimate of population parameter given by the two number of statistics. Thus, the population parameter lies between two number. Interval estimate is 0.038 to 0.052 means that population parameter is somewhere between 0.038 to 0.052. So, confidence level. Confidence level is the level of surety expressed in percentage. It is a degree of surety that the statistical measures obtained out of sample data represents entire population. For example, confidence level to be 90% for sample mean is equal to 25 means that person is 90% sure that the population mean is 25. Probability. Probability is expressed in decimal form, say 0.9 for 90% and 0.05 for 5%. Significance level. It is level of uncertainty. It is difference between one whole and confidence level. For example, 90% confidence level is equal to 100% minus 90%, that is 10% significance level. Similarly, 0.05 probability means 1 minus 0.05 and it will be equal to 0.95 of significance level. Standard normal value. It is value which depends on confidence level. Symbolically, we write it as Z. So, once again, whenever I say that population mean is equal to 50, as I have obtained sample mean as 50, then it is called point estimate. And whenever I say that I am 95% confident that population mean is between 40 to 60, as for calculation made from sample mean, then this is what we call as interval estimate. So here is the table of standard normal value, Z value for the given confidence level. So here we are going to learn about calculating interval estimate for population proportion. First of all, we need to calculate the standard error by using the following formula, where n is the number of items in the population and small n is equal to number of items in the sample. X is equals to number of success in the sample, whereas P is equal to proportion of success in the sample, which is obtained by dividing X from N. Q is equals to proportion of failure in the sample, which is equals to 1 minus P. Then at 1 minus alpha into 100% confidence level, we find standard normal value, Z value, from the table. For example, if confidence level is given 95, Z value is equals to 1.96. So, and the third one and the last one is to find out confidence limits, which is obtained by the following formula. So, lower limit will be given by P minus Z into standard error of P, and upper limit will be given by P plus Z into standard error of P. Here, let's learn to find out tabulated value of Z from T-table. Whenever sample size, that is n, is lesser than 30, we use to find Z value. Z value is obtained by the degree of freedom with df with infinity sign and various level of significance for two tail test. And for example, we have, when we are given 80% confidence level, we get 20% significance level, and that is 0.20 significant level. So z value at 80% confidence level becomes 1.282. And when we are given 95% of confidence level, we get 5% significance level, and that is 0.05 significance level. So z value at 95% confidence level is 1.960. From this table, we will be able to find z value when we will be given confidence level of 80%, 90%, 95%, 98%, and 99%. So here we have the problem for estimate for population proportion, which reads as follows. A political leader wants to estimate her popularity in a certain locality. A random sample of 600 persons was taken, and it was found that 280 were her supporters. Estimate the percentage of her supporters in the locality at 95% confidence level. Find sample error when n is 1000. So let's think about how are we going to do this problem. And here I have the solution. So first we should write, given sample population n is equal to 600 persons, number of success in the sample, that is x, is equals to 280 persons. Proportion of success in sample, that is p, is equals to x by p, is equals to 280 by 600, and we get 0.4667. And proportion of failure in sample, that is q, is equals to 1 minus 0.4667, will give you answer 0.5333. And so we apply the formula for standard error when n is known. And here, then after we get the standard error, we apply formula to obtain standard normal value of z. And here we get standard normal value of z for 95% is 1.960. We also use, it is to note that we also use 95% when no significance level is given. So at 95% confidence level, p is equal to 0.4667 plus minus 0.0204 into 1.960. And here we obtain this answer. For obtaining lower limit, we subtract this 0.0400 by our proportion of success in sample. And for obtaining upper limit, we add 0.0400 for our proportion of success in sample. So here we write the answer. The true population proportion lies in between 0.4267 to 0.5067, or 42.67% to 50.67%. Before we did question for when n is unknown. So let's try with the question when n is known. Here we have n given as 1000, and so when n is known, we have standard error of proportion is given here, and here we obtain 0.0166. So internal in estimate for population mean is calculated by the following step. First, we calculate sample mean by using following formula. This one. Then we calculate sample standard deviation using following formula, keeping following things in mind: that when n is lesser than or equals to 30, we we calculate adjusted sample deviation by or we calculate sample standard deviation using this formula for adjusted sample deviation and this for sample standard deviation. So we find then next the third step is that we find standard error of mean using the formula. For this formula is used when n is unknown, and this formula is used when n is known. And at last we fix the confidence level. When n is large, we find out standard normal value, that is z value, as we did it previously. And when n is small and this sigma is unknown, we use stable value of d. Degree of freedom is equal to n minus 1. Like for example, if n is equal to 10, then degree of freedom will be equals to 9. And here, this is how we check the distribution. So let's go to the problem. Here we have the problem for population mean, which reads as follows. Department of Agriculture is interested in estimating the mean yield of oilseed in Chitwan district. A random sample of 70 plots from that district showed the average yield of 700 kg per hectare with a standard deviation of 50 kg per hectare. Estimate the average yield of oilseed in Chitwan district at 95% confidence level, and how would the estimate be changed if confidence level was increased from 95% to 99%. So first you set how are you going to do in your mind, and here we have the solution. So it is given number of sample plots n is equals to 70 plots, average yield per of hectare, that is x bar, is equals to 700 kg, standard deviation per hectare sigma is equals to 50 kg. When n is unknown, we have this formula and we find out the required value using this formula, and here we get 5.9761 as an answer. So next is at 95% confidence level, z value is 1.96. Therefore, at 95% confidence level, limits of true population is given by mu is equal to x bar plus minus z into standard error of mean. And here we get answers. So for lower limit, we get 688.2868, and for upper limit we get 711.7132. So therefore, at 95% confidence level, the average yield of oil seeds from land of Chitwan district lies in between 688.2868 kg to 711.7132 kg. Hope you got this. So again, we were also given to find out at the confidence level of 99%. So here we write at 99% confidence level, z value is 2.576. At 99% confidence level, limits of true population is given by and this formula, and here we get this answer. This is for lower limit and this for upper limit. So therefore, at 99% confidence level, the average yield of oil seeds from land of Chitwan district lies in between 684.6056 kg to 715.3944 kg. So let's do for estimating in interval estimate for population mean. From a population of 1000, a sample of 150 is drawn from this sample is found 30 units and standard deviation is 5 units. What is the standard error of mean? What is the true population mean at 98% confidence level? So for this, here's the solution. We are given population n is equals to 1000 units. Sample population is equals to 150 units. Sample mean x bar is equals to 30 units and standard deviation sigma is equals to 5 units. Since we know the value of n, the value of standard error is given by this formula. And now after calculating, we obtain value of standard error as 0.3765. True population mean is given by mu is equal to x bar plus minus standard error of mean into z value. So standard normal value of z for 98% is 2.326. At 98% confidence level, mu is equals to 30 plus minus 0.3765 into 2.326, and so here we obtain lower limit as 29.1243 and upper limit as 30.8757. So therefore the true population mean lies in between 29.1243 units to 30.8757 units. Determination of sample size. Fixing size of sample out of population for finding sample statistics depends on nature, type, accuracy level, resources, and objective of research for data. So sample size of estimation of a population mean is given by this formula, where z is equals to value of z at 1 minus alpha into 100% confidence level. E is equals to error to be tolerated, that is x bar minus mu, difference between sample and population mean, and sigma hat is equal to estimated standard deviation. And another is sample size for estimation of a population proportion. N is equal to this n is obtained by using this formula, where z is equals to value of z at 1 minus alpha into 100% confidence level. This E is equals to error to be tolerated, which is the difference between sample and population proportion you are okay with, and P is bigger P is equal to population proportion of success, which can be obtained from past studies or similar studies. If P is unknown, we can fix P is equal to 0.5 because N will be maximum at P is equals to 0.5. So here we have the problem for determination of sample size, and the problem reads as follows. Department of Industry wants to estimate the average weight of cement bag produced by a certain industry by taking a sample. How large a sample will be required to be 99% confident that this sample mean will not differ from the true mean by more than 0.40 kg. The standard deviation of the weight of cement bag produced by the industry was known to be 1.5 kg. So here we have the solution for the given problem, and here we have z value at 99% confidence level. Z is equal to 2.576, error to be tolerated, E is equals to 0.40 kg, estimated standard deviation of weight of cement, that is sigma hat, is equals to 1.5 kg, and sample size of population mean n is equals to what? We have this formula for finding out the sample size from population mean, and here we obtain answer 93.3156, and when we round it off we get answer as 93. So we can say that sample size is 93. Another problem we have for the determination of sample size for proportion, and the problem reads as follows. If the population of success is 0.65 and n is equals to 100, what will be the value of sampling error when acceptance region is 0.95? So for this problem, here we have the solution. Given population proportion of success P is equals to 0.65, sample size of population mean n is equals to 100, error to be tolerated E is equals to what, Z value at 0.95 or 95% confidence level, Z is equals to 1.96. So here we have to find out E, value of E, and here this can be found out by this basic formula we have for n, and that is this. So let's make it an equation. N, and this n whole upon bigger P, 1 minus P bracket closed, and here we have Z upon E whole square, and so we obtain this. When we square both sides, we get a root of this root over here, and here we get a square over. And so after putting this formula, we obtain value of E as 0.0935. So therefore error to be tolerated is 0.0935 units. So all thing you require is to practice statistics from books using shown formats and formulas. So it was pleasure for me to share my knowledge via Adu's online study channel. More of the educational videos are on the way, so do press like button, share button and subscribe button, and do leave your valuable comments in comment box so that it would help us to improve our weakness and maintain better sides of us. So thank you.